Welcome back to the InfoFlex. In today's video, we are going to work with the VL53L0X laser distance sensor and connect to an Arduino to measure distance. So, if you are looking to add precise distance measurement to your next project, you are in the right place. So let's get started. Here, what you will need for this project: in Arduino, the VL53L0X sensor, an OLED display, some jumper wires, and breadboard. The VL53L0X distance sensor is a new generation time of flight laser ranging module housed in a small package on the market today, providing accurate distance measurement whatever the target reflectance is. Unlike conventional technologies, this sharp distance sensor can measure absolute distance up to 1.2 meters, setting a new benchmark in ranging performance levels, opening the door to various new applications. The VL53L0X is a time of flight distance sensor developed by ST Microelectronics. It measures the distance to an object by calculating the time it takes for light pulse to travel to object and back. The sensor contains an infrared laser emitter that emits a beam of light invisible to the human eye. The emitted laser beam travels through the air, reflected off a target object, and returns to the sensor. Connect the VCC pin of the VL53L0X to 3.3 volt pin of the Arduino. Connect the ground pin of the VL53L0X to ground pin of the Arduino. Connect the SCL pin of the VL53L0X to A5 pin of the Arduino. Connect the SDA pin of the VL53L0X to A4 pin of the Arduino. Next, let's wire up the SSD1306 OLED display. Connect the VCC pin of the OLED display to 5 volt pin of the Arduino. Connect the ground pin of the OLED display to ground pin of the Arduino. Connect the SCL pin of the OLED display to A5 pin of the Arduino. Connect the SDA pin of the OLED display to A4 pin of the Arduino. First, make sure you have the required library installed in your Arduino IDE. We will need the VL53L0X, Adafruit GFX, and Adafruit SSD libraries for sensor and display. You can install them by going to Sketch, Include Library, Manage Library, and search the required libraries. In code, we are dividing the reading by 10 to convert it from millimeter to centimeter. Now let's upload the code to our Arduino and see the magic happen. As you can see the distance reading, and as I move my hand closer or further from the sensor, the value updates in real time. This is simple and effective way to measure the distance with your Arduino projects. You can use this setup for all kind of application like robotics, security system, or even a DIV distance based counter. If you enjoyed this video, make sure to give it a thumbs up, subscribe to the channel and hit the notification bell so you never miss another project. Let me know in the comments what you plan to build with this sensor. Thanks for watching.